Hi, I'm Kirk Sabin, and I'm here today with Martin Gilpatrick. We're excited to introduce you to the first Virtex UltraScale all-programmable FPGA, the VU095. Virtex UltraScale devices are the industry's only high-end 20nm family, and today we're demonstrating one of the key high-end features, the GTY transceiver, capable of 32.75 gig short reach and 28.21 gig long reach operation. These line rates are required to implement next-generation 400 gig and 500 gig wired networking systems. Virtex UltraScale devices' capability to communicate with cutting-edge optics like CFP2, CFP4, or CDFP, combined with the capability to drive and receive over a backplane at 28 gig without a retimer, enables a whole new level of system integration. In conjunction with the 16.3 gig GTH transceiver, these systems can leverage new standards such as serial memories or even PCIe Gen 4. Let's take a look at the hardware.
The board we are using is the UC1283 with a Virtex UltraScale VU095 device in the socket. We have 3 quads enabled, the first running at the maximum rate of 32.75 gigabit per second into the scope, while the remaining 2 are connected to each end of the backplane, and while they're both running 28.21 gigabit per second, they're connected to separate clocks set to demonstrate an asynchronous interconnect. As with any transceiver, the basis of performance starts in the PLLs. The GTYs here are using one of the 2 LC tank PLLs available in each quad. The ranges of these LC PLLs are actually spaced to provide coverage from 1 gig all the way to 32.75 gig, with carefully selected overlap between them to maximize flexibility at those key line rates in the 10 gigabit and 25 gigabit per second ranges. So what do those PLLs in the advanced clocking distribution networks get us? 7 picoseconds of total jitter and 230 femtoseconds of random jitter. At 32.75 gigabit per second, this is 0.23 UI of total jitter, giving us more than enough margin to interface to the latest generation of pluggable optics.
And pluggable optics are one of the most important drivers of 25 and 28 gig line rates. Starting with CFP2 and progressing into QSFP28 and CFP4, the CEI 28 gig VSR specification has formed the basis of 100 gig optical interconnects. At 32.75 gig, our GTY is already exceeding those same specifications. This enables Xilinx to be ready for the next generation 400 gig CDFP optics that are coming soon. As throughput requirements increase, the density of the faceplate increases as well, driving these new optical standards. The corollary to the increasing bandwidth on the faceplate is the increasing need for bandwidth on the backplane.
After the broad adoption of 10 gig backplane applications, the next step in this space is between 25 and 28 gigabit per second per lane. Since a transceiver has to have both a transmitter and a receiver, we will now show you the GTY receiver working over the most difficult of channels. We have 2 quads running at 28.21 gigabit per second. The first is sourcing its clock from an onboard clock module, and the second from an external clock generator. This recreates what you would see in a real system, with unique clocks on different line cards, recreating the same stresses to the CDR. Likewise, this FCI backplane has a pair of XMX connectors and a length of trace that, when combined with the board and cabling, comes out to 27 dB of loss. This approaches the CEI 25 gig LR or 802.3 BJ specifications. Let's take a look at the sort of margin we have over this link. First and foremost, we have error-free operation over these 4 lanes as shown by Ibert. We are also able to use our internal iScan functionality to scan through an entire UI and determine the bit error rate at any point within that space. With all of this error-free space in blue, you can see here that we have a lot of margin, overcoming the difficult channel topology and clock offsets. The GTY can do this by utilizing its auto-adapting decision feedback equalizer, continuous time linear equalizer, and automatic gain control. Xilinx has had great success in the 7 series and UltraScale FPGA transceivers with our auto-adapting equalization, and we've brought that experience to bear at 28 gigabit per second with the UltraScale GTY transceiver. No other FPGA supplier can come close.
With all of this capability, Virtex UltraScale FPGAs support single chip N by 100 gig, 400 gig, and 500 gig applications, and enable the path to terabit systems. As you've seen today, Virtex UltraScale FPGAs, the industry's only high-end 20nm family, is available now and is delivering unprecedented levels of bandwidth and system integration for the most demanding applications. The new UltraScale GTY transceiver delivers the highest line rates available in the industry and the auto-adapting equalization capabilities to receive at those rates over the most challenging backplane topologies. For more information on Virtex UltraScale devices and the GTY transceiver, please visit Xilinx.com. Thank you for watching.